In this video, we're going to take a look at proportions, and we're going to focus on the sample proportion. So this is another way that we can analyze one categorical variable, and there's a couple terms that I want to cover first. So first off, we have measures of center and measures of variability for all data sets. And when we deal with categorical data, the measure of center is the population proportion or the sample proportion if it's from the sample. And the variability is the standard deviation, which is what is given right there. And the standard deviation is best approximated when we have the number of successes at least 10 and the number of failures at least 10. And you'll notice, I'll talk about this later on when we get to hypothesis testing and confidence interval, but the N is the sample size, P is the population proportion, and this has to do with deciding between later on using the binomial distribution or using the standard normal distribution. So that's kind of part of it, and we'll get to that later. So for right now, you can kind of ignore the standard deviation. I just want to focus on the proportion, the sample, and the population. Before I get there, I want to just reiterate something about the population and the sample. First off, the population is all of the individuals with the characteristic that we're interested in. And when we talk about the population, remember those are measurements from the population or population parameters. So a parameter is a measurement from the population. And generally we don't collect data on the population. We take a sample from the population. That sample should be representative of the population. In other words, it has the same characteristic that we're interested in studying or learning about, and also it is randomly chosen to help avoid or reduce bias. So when we take this random sample from the population, we have our sample, and that's where we're going to get our sample statistic from. So whenever you hear the term statistic, recall that's talking about a measurement from the sample. Now, later on, we'll talk about confidence intervals and hypothesis tests, but that's something we would do going the other direction. We would take information from the sample, and we'd use that information from the sample to draw an inference about the population, whether it's to estimate a parameter or evaluate a claim about a parameter. But again, we'll get to that later. Right now, we're only on this first arrow coming out of the population for that simple random sample, and we want to estimate a proportion. So recall, we looked at a frequency table not that long ago, and it was a frequency table from a survey of introductory stat students, and they had to identify for one of the question choices as a freshman, sophomore, junior, senior, super senior, and then also they could choose not to respond, and this was the frequency table that we constructed. So we'll use this information or this data to take a look at this, but we're going to focus in on the proportion of sophomores. And I'll tell you this right now, but the proportion of sophomores is going to end up being this 0.4831 right here. The relative frequency will really be that proportion, but there's a couple things I want to talk about before we get there. So first off, when we talk about the proportion, we have to reduce this to a binary type of outcome. Either the student is a sophomore or they're not a sophomore. They're a freshman, a junior, a senior, a super senior, or they didn't identify. So we're reducing that outcome to a binary type of response. We're only interested in those that are sophomores. So when we talk about the sample proportion, this is going to be denoted with a p hat. The p hat indicates that that's the sample proportion. P without the hat over the top of it is indicating, at least in our class, that it is a population proportion. Some textbooks will use the symbol pi for the population proportion, just so you're aware of that. N is going to be our sample size, so this would be the total number of individuals that were surveyed, and X would be the number of individuals with the characteristic that we're interested in. We're interested in individuals that are sophomores. Now let's take a look at calculating our sample proportion for the sophomores. Recall from our previous one of our previous slides, we had the frequency table on there, and we saw that the sample size for all of the students was 443. That's where we're getting the value of N from. X represents only individuals that identified as sophomores on the survey, and there were 214 sophomores. So when we identify P hat, our sample proportion, this is going to be X over N. It's the proportion of individuals that identify as sophomores, which would be 214 divided by 443, and that sample proportion comes out to be 0.4831. Typically, we express the proportion in terms of a decimal value, but sometimes when we're talking about it in context, we would say something like 48.31% of the students in Professor Fox's class are sophomores. So Generally, like for the math calculations, it'll be in the decimal format, and when we communicate it in written language or communicate it with other individuals, we'll communicate that as a percentage. So that's how we calculate the sample proportion for categorical data.